Today I will show the design of retaining wall on base part. Here is the base part. So I will show the only base part, not stem part. So at first I want to read the question first. Then artificial lake is constructed with a reinforced concrete cantilever retaining wall as shown figure. Here is a figure of the 20 feet. The soil based on the scheduled soil is gamma soil 118 pound per cubic feet and friction of angle 20 and the height of the cantilever wall. Retaining wall is 20 feet. The design, the base. Here is the base, only base part, and cantilever retaining. Assume the required data of the base. At first we will assume this die, this portion, which is thickness. Stem thickness is h by 8, which is taken from based on assumption or nothing to seams, and base of thickness 30 inches, which is 30 inches found here, and base thickness h by 12, which is 20 inches, 20 inches, and the base height h by 2, so 10 feet. Here is the 10 feet is the base height. So if we take the 20 inches here, the 30 inches here, then in the right side will be 49.2 inches and left side 40 into 8 inches. So project on the base on the stream, which is 0.17 h, which is 40.8 inches, which is 40.8 inches. The coefficient of active pressure to 1 sin pi by 1 plus sin pi 0.33, and for the steam force pressure K in gamma prime into H, gamma prime 118 minus overburden of water pressure, which is 366.3 pound per foot square, and 1 feet of steam calculated for 3.66.8 pound per feet. Now load will be 1.2 that plus 1.6 live load and 1.44 kg feet. Live load is 0 because there is no water, free water, and force or reaction force, which half into land into height and 1.44 inches square. So we will note this moment. Moment is 1/3 H into R, 29.33 kg. This moment will be calculated for steam wall, not base wall. So this moment will be used for steam wall, not base. So this is the very important important information for us. So this moment we will not use for back wall design. For base, we know the m not equal to r into x. R we have found 1.4, and x will be from the left side of the CG, which is 20. Sorry, here it will be upward. So 20 is the base thickness, and 1/3 h into here is a 20. So we have found 36.6 cubic feet. Now we know the basic equation. M equal to rho b, b equal to L bh, and rho equal to gamma, so unit weight. So W equal to B in gamma, which is V equal to volume, which is length, breadth, and height, and unit weight. So W1, here is a W1. This is the soil portion. W1 L equal to which 49.2. Here is the 49.2, and breadth this 1 feet and height into 240. So this is the W1, and W2 X will be 49.2. So this is the CG, and moment will be 9.7 into 2.09, 2.04. That will be moment M1. And W2, this is the wall portion, which is thickness is 30, B L, and B equal to 12, 1 feet, and height equal to 24. Here is the height of the 24. So height will be 20, and the unit weight one of 150. 150 is the unit weight of concrete, and we have found 7.5, and the CG will be 49.5 plus 30 divided by 2, because we will go to this portion. So I will change the color for the calculating of the second portion. Here is the second portion, so we have to go out from here. This is the CG, from it is here the CG is 49.2, 49.2 plus 30 divided by 2, 30 divided by 5.35. So we will multiply 7.5 into 5.35 and got the moment. And W3, here is the W3, the portion I have already found. Here is the number 3, the base portion, 120 is a breadth, and 12 is a B, and height is a 20 inch is the height. This so this will be, so I have mistaken, this will be 1240. Okay, because when we calculate W2, there is a W2, so the height will be 240, height will be 240. Okay, and W3 in the similarly, we have calculated 120 is the breadth, and to B equal to 1 feet, and height into 20 inches, and found 2.5 keep, and the CG will be from this point to this point. So 49.2, and 30 divided by 2. So W3 will be here, and force into distance I have found 32. So summation of all W is 19.7, and summation of resisting moment 73.8 kip feet. We have found the resisting moment 7.38, and the induced moment 30. Overturning moment 36.6. So our factor of safety is greater than 2, so we can say this is okay. So now we will calculate the A equal to MR minus M overturning divided by W. We have found 1.86, and eccentricity E equal to B by 2. Here is a B is a total base, and minus 1 A, and found 3.14 inches square. Here is a 3.14 inches square. It is the eccentricity of load. So C will be from base, left side of base, which is B minus A, and around 5 feet. So for a feet length of 14, 10 plus 1 into 10 square. So base moment of inertia of base 1 into 10 cube divided by 12, so 93.3 feet cube. So WD will be 1.2 into 10, so 19.7. We have W already found 19.7 here. All the summation of W, so found here 23.2. So we know the Q. How we will calculate the Q? We can calculate this formula or this formula. Both are correct. W by A into W into E into C divided by A, and putting this value, and from so plus 6.3 is a tension, and minus 2.6 compression. Or we can use this formula W by P plus minus WD into E divided by B square by C see, and putting this value and from say 6.8, 6.81 and minus 2.09 tension and compression compressibility. Two are same, two are equal same. So here is our compression value 2.09 and tension value 6.81. So let's start the front side calculation. We know the front side is here. We go to the main diagram. Here is the main diagram. This is the back side and this is the front side. So now we'll calculate the front side. Okay, so we are going to front side here. So front side we have found the maximum tension is 6.81 and compression 2.08. So we will find the Q max 1. Here is the front side Q max 1. We can see that two triangle we have compared. One is larger. Here is the green portion, which is 8.61 minus 2.63. This is the height, and the base distance we have found 120 inches square. We know that here 120 inches square divided by 12, which is taken for inches. So this is the large portion of triangle, and we are comparing with small portion. So this is the base in the red form, and height is we can say QX1, and the base will be 49.2 plus 30, and divided by 12 is taken into inches. So found QX1 is 2.58 KSL. This is basically just comparison between larger triangle to smaller triangle, and found the front side to moment, which is rectangle. Here is a rectangle, and we have shown the triangle because we are taking the front side. So we are calculating only this front side because we have already calculated. We have noticed that we are calculating front side. So this is two portion. One is a rectangle, another is triangle. So I have noticed the area will be rectangle here. Here the area will be 2.58. Here is the 2.58. 2.58 is length, and 40.8 will be the, here is the distance. Here is the distance 40.8. We have just seen here 40.8, and the CG will be 40.8 divided by 2. Here is the CG 40.8 divided by 2. So this is the rectangle portion. In the same way we are taking then change the color. This triangle has half into length into 6.81 minus 2.56. So this is the height, and base will be 40. Here is a 40.8. We have seen here 40.8 here, and the CG will be 2/3. So we are calculating from this side. That's why we're multiplying 2/3 of f 40.8. If we calculating from this from left side to right, then we are taking 1/3, but we are calculating from right side to left side. That's why we are taking 2/3. 40.8 divided by 12. 12 is taken to inches, and found 31.21 cubic feet, which is the only for front side. This is the front side. We are designed for this moment. Here is a moment. I will show the earlier. And back side we are calculating the back side. Back side is here. Now we will go to the main diagram. Here we can already see that this is the front side and this is the back side. Okay, so the back side, here is the back side. Now we are in the same way we are comparing the larger triangle into smaller triangle. At first we are taking 6.81 minus 2.09. There is a 6.81 and 2.09. That means this is this portion, and 120 divided by 2. 120 is a total base height. There is a total base height. Total base height divided by 12 is taken into feet. And qx1 we are changing the color. There is red color. qx1, qx2. Here is qx2. It will be 2. Sorry, it will be 2. And will be 49.2. 49.2 will be this portion, 49.2. So basically this is from larger triangle compared with smaller triangle to get the qx2 value, and we have found qx2 value 1.94, and 2.09 plus 1.94 will be sum or will be added, because of we are already found here 2.09. Here is the 2.09, and we will just sum up this value 1.94 and found 4.84 ks. Let's see how to calculate the moment of this portion. So moment will be this portion, is back side. So will be as like a similar I have earlier explained. There will be two types. One is rectangle. There is a rectangle, and another is a triangle. So at first we are calculating the rectangle. Here is the height of 2.09, and the base will be 49. Here is already shown, and it has seen here is 49.2. Here is this portion is 49.2, and the CG will be here 49.2 divided by 2, and again divided by 12 means is taken into feet. So this is the rectangle into it will be plus, sorry, it will be plus it will be rectangle. So I'm changing color to red color. This is the red color. So half into 49.2. Here is a 49.2. 49.2 is a length. Here is a 49.2, and 49.2. Sorry, 49.2 and 4.08 minus 2.9. Here is a 4.84 minus 2.09. So this portion, this height, and 2/3. Why we will take 2/3? Because we are going CG from right side to left side. That's why we are taking 2/3 of 49.2. Here is a 49.2, and divided by 12 means it is taken for inch to feet. So there is a 2.3 is taken from right side to left side, because we are going to the right angle. On the other hand, we are calculating from right angle to from CG, then we are taking 1/3. Okay, I hope that you can understand, and found 32.94. This is the sagging moment. We can just calculating the back side. We are also calculating back side, but this two portion only, these two portions. So this two portion is divided W1 and W3. There will be no W2 will be not calculating here, and erasing this W2. Okay, so here is a W1 and W2. At first W1 is a soil. Here is a soil. I am changing the color. Here is the soil, W1 soil. This portion soil. So 1.2 into W. W means volume into unit of soil. Volume, which is 49.2. Here is the length 49.2. I have already seen here 49.2. So this is the 49.2, 1, 1 is the breadth, 1 feet, and 20 is the height. We know that this height, where is 20, here is 20 is a 20 is this portion of height. Okay. So 20, and unit weight of soil we are taking 118 minus 62.5, as we are deducting the unit weight of water. Thus we have considered the pore water. Here is a saturated soil, and we have found 5.46 kip. In the same way, we are calculating W2, but not the full. I am just locating this value. This portion we will calculate. I am not calculating all the W2. I am not calculating here. I am just calculating this portion, because I will notify this is the hogging moment at base in back side only. So WC back 1.2 dead load back side only. There is a dead load equal to which will be volume into unit weight of concrete. So volume L will be 49.2. Here is 49.2, and divided by 12. It is mean from converting inch to feet, and B will be 1 feet, as we know the 1 feet of strip is calculating, and 20 is a here is a 20 is the height of the base. I am showing you here is the height of base is 20 inch. So it is taken here and found 14.8 kip. Yeah, so now we will calculate the moment in this point. So what will be the moment? Moment will be W1 into CG, and the same way W3 into CG. Okay, W1 we have calculating 5.46, and CG will be this portion. That means the 49.2 divided by 2. 49.2 divided by 2 and divided by 12. That means it is converted into inch to feet. In the same way, W3, here is the W3, this is this portion only, and W1 I am changing the color. W1 is the soil portion, this portion only I am shaded here, as we are calculating the backside only. So W1 into CG and W2 into CG from this side, and putting this value, and found 41.5 kip feet. Okay, now I will going to the design. Here is the design. The S is found 0.85 FM CFI 1 minus root over 1 minus 2 FM 5 root over FM B into D square divided by into BT. Or we will use this conventional method, which is A equal to SFI divided by 0.85 FM CB, which is 0.49 as, and as equal to m divided by 0.49 FYD minus a by 2, and found 0.35 inches square, and found 3.35 inches square. We will use this or use this. We can use this, but it is not used for you. This is taken from the Honorable Professor Dr. Kedaranath sir. And as minimum as equal to 200 divided by FY BD, and found minimum 0.80 inches square, and all the minimum 0.80 inches square. So we found the reinforcement here from this calculation. On the other hand, it is taken from the moment. At first we want to introduce the front side moment. I have already, here is the front side moment found 31.21. Here is the 31.21, and sagging back side is sagging and holding. Sagging 32.98. Here is a 32.98, and another one 41.5. Here is the 41.5. Here is the hogging moment, we can say. So we have found the moment. Then we can calculate the AS. This formula we can apply for getting the AS, and found 0.35. We have already shown 0.35. Here is the 0.35. In the same way, we will found 0.37 for this moment, 32.98, and we found 0.37 inches square for 41.5 moment we will get the as 0.47 inch square by this formula or this formula, but we will use this formula. And minimum reinforcement we will use this formula for which is 100 divided by FYBD, and found the minimum reinforcement. You can see the minimum reinforcement is greater than the actual reinforcement, so we will use the greater reinforcement, which is 0.81, and use number 4 bar, the area of 4 bar 0.79. So spacing will be as b divided by as, which is 11.88 inches square, 11.88 in 11.88. So we can conclude that number 8 bar 11.88 inches square center to center from side front side of the base, and sagging of the base and hogging of the base. So this is our base. This is the base. We have shown the reinforcement. We know the stem wall thickness is 30 inches square and base thickness 20 inches square, and found the sagging moment. Here the sagging moment, the reinforcement is number 8 bar at the rate of 11.88 inches square center to center. Here is the reinforcement, and we both, and top and bottom we have used the same reinforcement. On the other hand, the hogging moment we have used here top and bottom the same reinforcement, 11.66 inches square. So I hope that this is our final diagram. So we can again we can what I will say we can summarize this. That is, at first we will assume some data, which is stem thickness, base thickness. Stem thickness is by 8 and base thickness is by 12 and base length is by 2, and projected base will be 1.78, and found the stem will be gamma as gamma is, and force will be stress into pressure into one strip, and unit weight load will be 1.2 into dead load plus 1.6 live load. Dead load will be here, which we have found the F or reaction 36.6 is, and we will found the reaction or force up into length into height and 4.44, and we can take the moment this force as 1/3 h into r. This moment will be calculated only for stem wall, not for base wall, as we are taking it. For base wall we are calculating the overturning moment r into x. R will be 4.44 and x will be 20 plus 1/3 into h. Here is here, and we are taking the same way w. We know the we are calculating resisting moment, which is w into x. We are calculating w 3 portion. We are dividing it into 3 portion, which is w1, w2 and w3, and x is the specified CG of the w1 to 3 portions, and found here a resisting moment. In the same way, we are found the factor of safety, eccentricity, and we calculate the stress, which is compression stress and tension stress. We can use this formula W by A plus minus W into E into C divided by I, or WD divided by B plus minus WD into C divided by B square by 6. W means 23.46. We have found here we have found W 19.8. We are calculating here 19.7 and multiply this factor 1.2 and found here. So in this way we can say the compression 0.29 and tension 6.48 kPa. So now this formula will use from front side, and the back side will be calculated. The front side we are taking here the comparing the larger triangle into the smaller triangle. So here is a larger triangle and here is a smaller triangle, and found WQX1. and taking the moment rectangle and triangle. Here is the two portion is a rectangle and the triangle, and found 30.21, and the back side we are calculating this is the back side. And in the same way the larger triangle, here is the larger triangle, and here is the smaller triangle, here is the smaller triangle, and found qx2. In the same way we will taking the moment. Here the two portion, one is rectangle and other is triangle, and found the moment. In the same way the hogging moment will be this portion, the soil and base portion. I will not take the whole portion of base, because we are taking the back side only, that's why we will take the w2 back side only. In this way we will take w1 and wt, and taking moment of back side, which is hogging, w1 into cg, w2 into cg, and found 41.5. And we are taking this moment in this here, and we will take the s. We are saying that the moment formula will be used this. We can use also here, but I will prefer we can use this formula. We can use also this formula, but we will not. I will not consider recommend this. And the minimum reinforcement is the formula will be 20 divided by FYPT, and found this, and the spacing will be here. So here is our final diagram of the base detailing of the reinforcement. I hope that you can understand my talk. If you have any question, then ask me or comment.